Hi everyone, so today we are going to continue graphing. Nothing new, it's the same lesson as Monday. I just wanted to give you guys another day of practice, and we're going to do a little bit more with fractions. All right, so here's an SAT question, right, from a practice test. You should know how to do this, like we just learned that. If t is greater than 0, t squared minus 4 equals 0. So how do you solve that? So you have two choices. You can factor t plus 2, that's a dots, t minus 2 equals 0, t plus 2 equals 0, t minus 2 equals 0. So we get t equals negative 2 and t equals 2. So this is a grid-in problem, so it's one of the ones where you would put the 2 in the problem and then bubble in a 2, right? You also could have added 4 to both sides, so t squared equals 4, take the square root. So because it says greater than 0, and on the SAT, you never have negatives for grid-in. Like, there's not an option for that, so you always need to pick your positive answer anyways. All right, so I want you to pause the video, find your vertex, your roots, your y-intercept, and your symmetric point. So vertex is negative b over 2a, so negative b over 2a, negative 6 over 2 times 1 is 3. So I get 3, comma, and then I'm just going to plug in, right, to find our y. This is an x, so to find the y we plug in, so 3 squared minus 6 times 3 minus 16. I get negative 25. And that's why I gave you the lines instead of an actual grid. And then to find our roots, remember we set our equation equal to 0. X squared minus 6x minus 16 equals 0. That's an MC chart. What multiplies to negative 16 combines to 6. So that's 2 and 8, and the 8 is negative. So x plus 2 times x minus 8 equals 0. So my roots are negative 2 and 8. And when we solve, we end up switching the sign. Our y-intercept is whatever our c value is, right? Because our x is 0. Our y is negative 16. And then the symmetric point, remember, we're taking 0, 16, and we're flipping it over the vertex. We're flipping it over 3. So basically, how far away is 0 from 3? 3, and then we do that again. So 3 and 3 is 6. All right, so those are our points. So now we're going to go through and graph. So start by putting some points on the graph. So my lowest y value is negative 25, so I'm going to put that there. I also need negative 16, so let's see. Negative 16 will be about here. Got the negative. I have to go over to 8, and then negative 2 looks about there. If that's 8, then I would say 3 is about here. Now I'm going to plot my points. So I have 3, negative 25. I have 0, negative 16. 6, negative 16, that'll be about here. And then my roots, which are 8 and negative 2. And then remember, I like you guys to label the points that aren't crossing something that we know. So 3, negative 25. And 6, negative 16. So we're going to label those two. Everything else is good, and we are done. All right, here's another one. Exactly same process. Pause. Do this on your own. All right, so I did this out of order. Roots are first in this one. So I'm going to factor, right? 0 equals. We are multiplying to negative 24, combining to 5. So that's 3 times 8, where 3 is the negative. So we get x minus 3 and x plus 8 equals 0. So x minus 3 equals 0, x plus 8 equals 0. So we get 3 and negative 8. So those are our zeros. Now our vertex in this one are negative b over 2a. I'm going to come over here and do that. I'm going to have to erase this later. I just don't have the room. So our negative b over 2a, so negative 5 over 2. So we do get a decimal. I'm going to put negative 2.5. Since it is a decimal that ends, I'm not really going to worry too much about it. I'm going to plug in negative 2.5. Make sure you use parentheses around the negative because that will change your sign. And I get negative 30.25 when I plugged in on my calculator. My y-intercept is, again, my c value. We reflect that point over our vertex. So our vertex was negative 2.5. So if I reflect over that 2.5 and 2.5 gives me 5. So it's negative 5. And then my y is the same. Axis of symmetry, x equals the vertex. All right, so we're going to go through and label. So I need to go down to 24. No, I have to go down to 30. So there's negative 30. I need to go over to negative 8, over to 3. And do your best to make sure that these numbers are kind of accurate in terms of like where they should go. So if that's negative 30, I need negative 24. So that's not going to be half is 15. So that would be there. So I'm going to say 24 is like here. All right, so just doing the best I can with it. And then I need negative 2.5. So let's see. I'm just going to go through. That's 4. So I'm just going to put all the dots, all the dashes. All right, so now I'm going to put my dots. I've got negative 8, 3, 0, negative 24, negative 5, negative 24. So it's going to be like here. Negative 2.5, negative 30.25. So it's like here. And those are my points. And then I'm going to label my vertex as negative 2.5, negative 30.25. And I'm going to label my symmetric point as negative 5, negative 24. Because, again, those points are out in the middle of nowhere. I don't want to assume anything, right? All right, next one. This one's a little different because it's a different type of factoring. So pause and try this one now. All right, so this is a dots, right? When I factor this, I get 2x plus 5, 2x minus 5. So when I solve it, I get negative 5 over 2, or negative 2.5, and positive 5 over 2. Now for my vertex, remember negative b over 2a, what's the b value here? Well, there's no b value because the x is missing, so it's just 0. It's negative 0 over 4, which is just 0. And then when I plug 0 in, I get negative 25. And notice what's the y-intercept? The exact same thing. And when these two are, when the vertex and the y-intercept are the same, there is no symmetric point. So I'm just going to put NA. Axis of symmetry is x equals my vertex 0. So we don't have as many points here, right? We only really have 3 points. We have our vertex and we have our roots. So we got 2.5. So I'm going to go 1, 2, 3, 1, 2, 3. And then down here is negative 25. So 0, negative 25, and then 2.5, negative 2.5. And that is pretty much all we can do. We're done. Nice, easy one. All right, last problem. This one has nice answers. So the roots, how do you factor this guy? This is a GCF. All right, so pause, do a GCF, and then do all the things. So we got negative 3x is our GCF, and when I factor, I get x minus 3. Set those equal to 0, so we get x equals 0 and x equals 3. My vertex is negative b over 2a. I'm going to do that up on the right. So negative b, my b is 9 over 2a. That's negative 9 over negative 6, which is 3 over 2, and then that's 1.5. So my vertex is 1.5, comma, plug that in, what do you get? When I plugged in, I got 6.75. My y-intercept, what's the c value here? It is 0. 0, 0. The symmetric point, if I reflect 0, 0 over the vertex 1.5, 0 to 1.5 is 1.5, and then 1.5 more, so that's 3, 0. X is symmetry, x equals. All right, so plot our points. We have x equals 0, x equals 3, it's going to be a tiny one. 1.5, positive 6.25, so 1.5, and then I'm pretty close to 7, something like that. 0, 0, 3, like notice the y-intercept and symmetric point are the same as the roots, so there's not much to do here. We only have those 3 points. And then I'm going to label that point as 1.5, comma 6.75, so there's no question about what point that is. And we are done. All right, so your homework is more practice of this, nothing really very different. And then also some practice with factoring and solving, because that's really important. We're going to be doing that all year, so I thought we needed a little review on that.